What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Of course, all these prohibitions are controlled by sensors in the air conditioning system. And unfortunately, they can be wrong. Very soon spring will come, drivers will have more desire to blow cold into the cabin, but some of them will be surprised to notice that after winter air conditioner suddenly stopped working, it happens. The first desire is to go to the workshop and to refill the system with Freon. Of course, many refuelers will be only glad to do it. One of my acquaintances from this sphere has already whispered to me that the cost of Freon has grown almost 3 times, so the service will become much more expensive. But is it always so necessary? Maybe it's not about Freon. Let's see what sensors there are in the air conditioning system and how they can ruin the life of the car owner. Cooled, boiled, cooled. I suggest to remember very briefly the general scheme of a typical air conditioner. We need it for one simple reason, to orientate on which elements there may be sensors and what they control. So, we press AC and hear a characteristic click of the compressor. That's at best. Sometimes we do not hear it, but we will talk about the suffering a little below. What is happening in the car at this moment? The click is the compressor clutch engaging. If it can be heard, it means that the compressor has started working. Although there are some cars, mostly German, in which the compressor is always working, but we are dealing with the most popular and typical scheme. From this moment the compressor starts compressing Freon and driving it through the tube to the condenser. It is also the radiator of the air conditioner. Freon comes there very hot, it heats up during compression, and in the condenser it should be cooled down. That is why in most cars, when you turn on the air conditioner, the fan starts working at once. This is a very important point, and it should be remembered. So, the fan blows on the condenser, Freon, and it cools down. What happens to it? Physicists and chemists have already understood everything. It goes into liquid state, i.e. it condenses. That's why the radiator of the air conditioner is called condenser, not just radiator. From there the liquid Freon flows further to the filter dryer, aka receiver dryer or filter dryer. This is a rather simple, but very necessary thing, a long tube, inside of which lies an adsorbent, usually zeolite. The main task of the dehumidifier is to absorb all the water that gets into the Freon with the air. If it is not done, the water will freeze into ice, clog the mains, and the conditioner will not work. And this is the second important position, which I ask you to remember. Well, and at the same time filter dryer removes unnecessary mechanical impurities from liquid Freon, as a rule, products of inevitable wear of compressor. After the dehumidifier, the Freon is ready to perform its first task, to quickly become very cold to cool down the passenger compartment. To do this, it has to undergo another procedure, to quickly change from liquid to gaseous, i.e. to boil. This process is accompanied by a large absorption of heat, and the Freon cools down a lot. Physically at this point the following happens: Freon passes through the thermostatic control valve and enters the evaporator, where it boils, cooling the evaporator body. Here, roughly speaking, a fan blows on this case, which drives cold air from it into the cabin air deflectors. Meanwhile, Freon from the evaporator again runs into the compressor. At this moment it is still quite cold and, of course, gaseous. That is, ready to be compressed, cooled, condensed, purified, boiled and returned to the compressor again and again. There are 2 sections in this rather large system. One is the section between the compressor and the thermostatic control valve, the other between it, or the evaporator, and the compressor. The first section is called the pressure line, or high pressure line. The second section is called the return line, low pressure line. They can be easily distinguished by touch. The tubes of the first one will be hot at normal operation of the air conditioner, the second one, cold. It is a little vulgar, but it is easy to describe the scheme of air conditioner operation. Now it is time to return to those important things which I noted in the paragraphs above, to the moment of compressor and fan switching on and to possible water freezing. All these processes and their consequences are monitored by sensors, each of which can shut down the air conditioner. Do no harm. The most likely adversary to turning the air conditioner on is the low pressure sensor. This is the same sensor which has only two positions on and off and uses its second position to open the compressor circuit. It does this in one case when the Freon pressure drops critically. It would seem, what does it care about pressure? It does care. Freon has a lubricating component which is necessary for compressor operation. If there is not enough Freon, there will not be enough lubrication for the compressor and it will fail. However, in a very critical situation, you can close the circuit directly, bypassing this sensor. This is a good way to check if the compressor is intact. If it works after that, you should not rejoice, but quickly turn it off. Working with insufficient Freon pressure is very harmful for it. Well, and look for the reason of refusal to turn on with the sensor. Most likely, the reason really lies in a drop in pressure. Most often the compressor stops working when the pressure in the return line drops below 0.7 atm, but sometimes it can be a little higher. You need to know this parameter for a particular car, but sometimes it is the sensor that is to blame. Not everyone can check it, because it can be both simple 2-pin and more complex 3 and even 4-pin. It is better to do it in a service. In addition to the low pressure sensor, there is a second pressure sensor, the high pressure sensor. Remember I said just above that if the filter dryer is not doing its job, there can be water left in the Freon, which can easily freeze. Ice is such an automobile clot in the air conditioning system. If it clogs a tube, the pressure will skyrocket and eventually something is bound to burst. This something will be at best a tube, at worst an evaporator or any more expensive part, although often tubes cost so much that you want to weep, especially today. Or the compressor may even die. The high-pressure sensor triggers when the pressure rises to an average of 25 atm, although the system can survive 30 atm for a short time. Prolonged operation at too high pressure kills the system, so it prefers to shut down, which the high-pressure sensor helps to do. There is one sign that can sometimes help to determine which sensor is preventing the air conditioner from working. If the low-pressure sensor is at fault, the maximum thing that will happen after the air conditioner is turned on is that the AC light will come on, and not always, it depends on the car. But if the high-pressure sensor is triggered, the condenser fan may turn on. However, this will only work if there is a 4-pin sensor. In any case, it is better to deal with it in the service. And if it is not pressure, probably you have often met information that if it is colder than +5 outside, the conditioner will not turn on. It is so, and the sensor, air temperature sensor, is also to blame. Thus this caring electronic guy saves the compressor. Freon at +5 degrees outside does not have time to evaporate completely and can get into the compressor in liquid form, and it will not survive such a situation. Unfortunately, the air temperature sensor is not eternal either, and even though very rarely, it can fail. Another sensor, which is also not always present, monitors the coolant temperature and switches off the conditioner if the antifreeze temperature rises above 110 to 120 degrees. Here the logic is clear. Condenser operation requires active cooling by fan, and as condenser more often stands in a dense sandwich with radiator of cooling system, the latter starts to warm up from condenser, especially if the radiator pack is too dirty. In this case, it is better for the driver to melt from heat than to overheat the engine. Another harmful sensor is the evaporator temperature sensor. Its task is to prevent the evaporator from freezing at all and covering with an icy coat. If it doesn't work, the troubles can be various, from constant work of the air conditioner at full blast to compressor shutdown. Here much depends on what signal comes from the dead sensor, whether it shows that the evaporator is covered with an ice coat or that it is too warm. Besides all listed sensors, there are some more, which can work incorrectly, but which at least are not able to turn off the air conditioner finally. And, by and large, they refer not so much to the air conditioner as to the climate control system. They are, for example, sensor of intensity of solar radiation, light, or sensor of temperature in the cabin. If they stop working, which, frankly speaking, happens rarely, the climate control will go crazy. It will stop understanding whether it is too cold or too hot in the cabin. However, the air conditioner will work in manual mode. I would like to finish with one reminder: in most cases it is not reliable sensors that are to blame for air conditioner failure, but Freon pressure. Therefore, before you run for a multimeter or oscilloscope, you should take a manometer in your hands and check pressure in the system. Or go to a service where it will be done, not too expensive, but quickly. In conclusion, understanding the role of sensors in air conditioning systems is crucial for optimizing comfort and energy efficiency. By accurately detecting temperature and humidity levels, these sensors ensure that your air conditioner operates only when necessary, preventing unnecessary energy consumption. Whether it's a temperature sensor, humidity sensor, or occupancy sensor, each plays a vital role in maintaining the ideal indoor climate. As we continue to advance in technology, these sensors will only become more sophisticated, helping us create more comfortable living environments while being mindful of energy use. Thank you for watching, and stay tuned for more insights on home comfort solutions.